Hmm. Now let's start. Okay, I hope everybody remembers last class we drawn this one. So x less than 0 and x greater than equal to 0. So this diagram we drawn. Can anybody tell me by looking at this diagram, is there any break? Is there any break in the graph? Look at it carefully. Is there any break? Yes or no? If it's there, then where is the break? Is there any break? If I try to draw the graph of this one, if I try to draw this graph, so how will I draw? If I try to draw the graph, I will just draw like this, right? This and this. Yes or no? Clear? So do I lift my pen while drawing this graph? Do I lift my pen while drawing this graph? No, right? So it means what? There is no break in this graph. There is no break in this modulus function. And first thing first, what you need to see is whether this function is defined or not. Now, I told you yesterday that when can a function be undefined? When can a function be undefined? A function can be undefined when it has what? When we have anything divided by 0. Anything divided by 0 makes a function undefined. Or we can have root over of a negative number. This also makes a function undefined. Understood? Am I clear? Yes or no? Now tell me,
Yes, sir.
in this function fx, do you see any denominator? In this function fx, do you see any denominator? No, right? Do you see any square root? Do you see any square root? Mute your audio. Do you see any square root? Hey guys, please mute your audio, everyone. Mute your audio, everyone. Eh, Now look at here. So what we say, there is no square root in here and there is no denominator in here. So it means what? If both of them are not here, so it means this function is defined for all values of x. So this function can never be undefined. So the function is defined at every point on the real line. So at every point on the real line means what? For every value, for every real number, the function is defined. Now, the graph of the function shows that there is no break. You see, there is no break. It's just a straight line like this. You see, there is no break. So I can draw this graph without lifting my pen. Okay. Now, so we can say that the function fx is continuous for all values of x. Since we can draw the graph without lifting my pen, we can say that the function is continuous for all values of x. Yesterday we learned what? This function was not continuous. Why? We drawn this one, then at the point 0 it was true. Then we drawn this one again. Am I clear? Understood? So there was a break at the point x equal to 0 and that was 2. So we cannot draw it without lifting my pen. So we have to lift my pen at the point 0. So this one was not continuous. This was discontinuous at x equal to 0. Now another example we did last class, it was this one. Again, we see the graph is going this direction. Okay, and it's coming at 1. And in the right hand side, at the value at x equal to 0, the value of fx, the value of y is 1. It's not 2. That's why here we have a hollow circle. That's why we had a hollow circle in here. And then when x is greater than 0, when x is 1, when x is 2, when x is 3, the value is 2, 2, 2, like that. Okay, clear? Now, acha, somebody has joined. Wait a sec. Hey, everyone, mute. I am unmuting you guys to. Now look at here. So this, I hope everybody have understood. What do you mean by continuous and what do you mean by discontinuous function? So continuous function is what? I cannot, I guess I have to mute everyone. So continuous function are those functions in which if I draw the graph of it, then we don't have to lift my pen. So that's what a continuous function is, right? So now, what is the mathematical definition? This is what graphical definition of continuous function. Now, what is the mathematical definition? Last class we did. Mathematical definition is, suppose I have a function. Let me draw this one. So suppose I have a function, this one goes here and this one goes in here. This is x and y. Okay, this one is your x axis and this one is your y axis. Okay, now if I have a function which goes on like this, understood? Clear? And I have to check whether this function is continuous at one point or not, and let that point be, I mark that point to be 5. Okay, Achha, let's do with another ink. Let's do with green. So I have to check what, whether the function is continuous at the point 5 or not. So in order to check whether a function is continuous at 5 or not, what I will do, I will draw a line like this. I will draw a straight line from the point 5 to the function, this one. Everyone clear? Yes or no? So this point is actually what? This point means the value of the function at the point x equal to 5. So this point is actually f of 5. The value of the function, the value of fx at the point 5. So that's what f of 5 is. If I draw a line from 5 to this function, so this point at which this line will cut is actually f of 5. Now, next what I will do, I will try to draw another line. I will try to draw another line like this. In the right hand side, it will be like this. Okay. Now I will try to draw another line in the left hand side of 5. It will be like this. Now why am I drawing this thing? The reason is I will mark this point as f of 5. I will mark this point as f of 5. Acha, what do you mean by f of 5 minus? What do you mean by 5 minus? 5 minus means less than 5, and less than 5 means what? It lies in the left hand side of 5. And this one I will mark as 5 plus. 5 plus means what? Greater than 5. Okay? Clear? Acha, wait. I need response from you guys. Everyone, please mute your audio. When I say something, then only you can. Okay, now others, I guess you have unmute. Now look at here. So we will draw this diagram to check whether a function is continuous or not mathematically. I got 5 minus, I got 5 plus, I got 5. Now how to check? The first thing I need to check is the left hand limit. Let us find the left hand limit. So what will be the left hand limit? How can I find left hand limit? The left hand limit will be given as LHL will be given as limit x tends to, can anybody tell me what will be the left hand limit at the point 5? What will be the left hand limit at the point 5? It will be limit x tends to 5 minus fx. Okay, that is our left hand limit. Now next thing I find the right hand limit. Right hand limit is what? Limit x tends to 5 plus. Okay, f of x. This is the right hand limit. Now the next one, I found the limit at 5 minus. I found the limit at 5 minus. I found the limit at 5 plus. Then what I will find? I find the value of the function at 0.5, and that is what? F of 5. Then how can I say a function is continuous at 5? If all these values, if left hand limit, right hand limit and the value of the function at the point all converges at one value. Okay, have you understood? If all these three are equal, then only we can say that the function fx is continuous at the point 5. Am I clear? Everyone, yes or no? Yes or no? So if all these three values are equal, equal means what? If all these three values converge at one point, it means what? This region has the same value. Okay, clear? So now let's do some problem. This Probit, who's Probit? Probit, please mute your audio. Probit, please mute your audio. Now look at here. So this is what I get. Now look at the function in here. Yeah, this Probit, what are you doing? Yes, please mute your audio, Probit. Now, continuity. A function is continuous at x equal to c if the function is defined at c. Defined at c means what? Here you see it was defined for all values of x, right? It is not undefined. Now, the first thing, the first condition is the function has to be defined at c. It cannot be undefined at c. Then what we can say? And if the value of the function at x equal to c, what is the value of the function at x equal to c? It is given by what? F of c. F of c is the value of the function at x equal to c equals the limit of the function at x equal to c. Okay, now listen very carefully. Everyone listen. I hope this one you learned in class 11. This one I hope you guys learned in class 11. If I say limit x tends to 5 minus fx is equal to limit x tends to 5 plus fx. If these two are equal, if left hand limit is equal to right hand limit, then what we can say? Then we can say that the limit exists. If the limit exists, then combining these two, I can write limit x tends to 5, x tends to 5 fx. Understood? I am combining these two. 5 minus means what? The value of x is coming from left hand side. 5 plus means what? The value of x is coming from right hand side. And 5 means what? The value of x is coming from both the side. From left hand side also, from right hand side also. Here they have specified which side they are coming. But if they are equal, then we can say that the limit at the limit of the function at x equal to 5. Am I clear? Yes or no? Combining the left hand limit and right hand limit, we get this thing. Okay? So that's why it mentioned in here. The value of function at x equal to c must be equal to the limit of the function at x equal to c. Now when they are saying limit of the function, it means that left hand limit is equal to right hand limit. So that's why they said limit x tends to c. They are not saying limit x tends to c minus or limit x tends to c plus, because they have already said that the limit exists. Limit of the function at x equal to c. Am I clear, everyone? Yes or no? So here it means actually what? The left hand limit is equal to right hand limit is equal to this one. Okay? And both that left hand limit and right hand limit are inside this one. This thing. Okay? Now, if f is discontinuous at c. Now, if I find out that f is discontinuous at c, look at here. We found out here. In here, the function was discontinuous at the point 0. Yes or no? Because left hand limit is not equal to right hand limit. The function was discontinuous at 0. And in here you see, this function is discontinuous at 0. Why? Because the left hand limit is equal to right hand limit. But it is not equal to the value of the function at 2. Yes or no? Everyone clear? Understood? So here we can say what? The function is not continuous. Why the function is not continuous? Because LHL is not equal to RHL. So we can say limit does not exist. Limit does not exist. So here the function is not continuous. Why? Because the limit does not exist. Now here the function is not continuous at x equal to 0. Why? Because LHL is equal to RHL. Here LHL is equal to RHL. But what? But here that LHL is equal to RHL is not equal to the value of the function at the point 0. Everyone clear? Yes or no? Understood? Okay, LHL is equal to RHL, LHL is equal to RHL, but it's not equal to the value of the function at the point 2. Okay, so now if I have a point of discontinuous, if f is discontinuous at C and C is called the point of discontinuity of f, so C will be known as point of discontinuity of f. Okay, so here 0 will be known as the point of discontinuity of this function. Understood? And here also 0 will be known as the point of discontinuity of this function. Okay? Understood? I hope everybody is clear about this one. Wait a second. Everyone is clear? Yes or no? Yes. So let's move on to the next portion. Now I have given the recording. I will give the recording after this class, I guess. Now continuity. What do you mean by continuity? Now there is another definition. A real function f is said to be continuous if it is continuous at every point in the domain of f. Now it is continuous at every point means what? It is continuous at every point means what? It is continuous at 1. It is continuous at 2. It is continuous at 3. It is continuous at, what should I say? Minus 1, minus 2, minus 3, 1, 2, 5, like this. If I say a function is continuous, then the function has to be continuous at every single point. Understood? Here the function is not continuous because it's not continuous at the point 0. But if you look at this function, it is continuous at every single point. How we know that it's continuous? Because you just draw a line. You see, for every value of x, there is a y. You just do one thing. If you draw a line and it cuts this one, and there is a uniformity. There is a uniformity in here. So we can say that this function is continuous. Understood? There is no break in here. There is no gap in here. Clear? So a function is known as continuous if it is continuous at every point in the domain of f. Now domain means what? Domain is all the possible values of x for which the function is defined. So that's what domain is. Understood? Am I clear? Now next one. A function is defined on the closed interval a comma b. A function defined on a closed interval a comma b. They have already told that it's defined. The function is defined on a closed interval a comma b is said to be continuous if f is continuous at every point in a comma b, including the endpoints a and b. So what does it mean? So they're telling that there is a function. So there is a function. What is the function they're talking about? Let me do. So first thing, there is a point A. So here we have a point A. Okay, clear? And there is a point B. There is a point B. Okay, and it's given as B like this. Now, there is a function within this A and B. Achha, listen carefully. Closed interval A and B. Here they are talking about closed interval A and B means what? Closed interval means what? Closed interval means the value of x cannot go beyond this. Yes or no? And the value of x cannot go beyond this. Yes or no? Everybody understood? Yes or no? A and B are the endpoints. A and B are the endpoints. Now, suppose if I have a function. If I have a function like this. Now somebody asks you, whether this one is a continuous function or not. So what you will say? So first thing you see that there is a continuity at every single point. There is no break in this graph, right? So if you pick any point, if you pick any point between A and B, if you pick any point between A and B, suppose you take C. Can anybody tell me, please tell me this one. Wait a second. Can you tell me one thing, whether the left hand limit and right hand limit, or the value of the function at the point, let's see, or the value of the function at that point C, acha LHL, RHL, left hand limit at C and right hand limit at C. Can anybody tell me whether they are converging at one point or not? Please tell me. Are they converging at one point or not? Yes or no?
Yes, sir.
Yes, they are converging at one point, right? This Probit and seriously. So they are all converging at one point. So can I say for every single point on this function, I can find left hand limit and right hand limit and the value of that point, and we have that the function is continuous? Yes or no? For every single point on this function? Yes or no, guys? Yes or no? Tell me fast.
Yes, sir.
Yes. Now I will pick a point A. Now if I pick this point A, for this point A, I have a line like this. Yes or no? Yes or no? Clear? Now, can anybody tell me, for this point A, will there be a left hand limit? For this point A, will there be a left hand limit? Think and tell me, will there be a left hand limit at this point A? Think and say. Pass. Pass. Look at here, there will be no left hand limit at the point A. Why? Because at A it's closed. The gate is closed at A. Look, to find left hand limit, I need to take a value less than A, right? But I cannot find less than A. Why? Because at the point A it's closed. So we can never find the left hand limit. Everyone clear? Yes or no? Yes or no? Everyone understood?
Yes, sir.
So what we can say, at the point A, we can only find the right hand limit and the value of the function at the point. So at the point A, we can find only the right hand limit and the value of the function at the point A. Understood? So then how can I check whether the function is continuous or not? Because in order to check a function to be continuous, I need left hand limit, I need right hand limit, and I need the value of the function at the point A, right? Yes or no? Yes or no? Yes or no? So what I will do, at the end point, continuity of a function at A means the right hand limit plus FA. If these two are equal, I don't have to find left hand limit. If these two are equal, then I can say that the function is continuous at A. Am I clear? So at the end point, I will say that right hand limit is equal to FA, the function is continuous. Understood, everyone? Yes or no? Yes or no?
Yes, sir.
Now tell me at this end point. Then you tell me at this end point. What will be the condition at point B? Tell me fast. At point B, what will be the condition? Can I find right hand limit at point B? Tell me, guys. Can I find right hand limit at point B? We cannot find right hand limit because At the point B, the gate is closed. I cannot have values of B more than B. I cannot have values of X more than B. Understood? Yes or no? So what we can find? So what we can find at the point B? I can find only the left hand limit at the point B. Yes or no? Yes or no? So I can find,
yes, sir.
yes, so write down. So I can find only the left hand limit at the point B. So what is the condition for this endpoint? The condition for the extreme endpoint will be left hand limit must be equal to FB, and that is it. If I find these two are equal, the function is continuous at B. Everyone clear? You see, left hand limit is equal to FB. So that's the condition we have to satisfy for the endpoints. Understood, everyone? I hope it's very, very clear. Yes or no? Now, now, if f is defined at only at one point, it is continuous there. That is, if a domain of f is a singleton, f is a continuous function. Now here we have a question. Here we had the function. Now suppose a function is like this. Now a question comes. If a function is singleton means what? There is only one value. Am I clear? Yes or no? Singleton means what? There is no values at all. There is only one value. So it means it's like this. It's like this. So at 5, so the function is defined only at one point. The other points, the function has no value. Everyone clear? Yes or no? Okay, so the function is defined only at one point. The function is singleton. Only one value is there. So what happens to this function? So to this function, we don't have to find the left hand limit and right hand limit. We don't have to find the left hand limit or the right hand limit. All we need to do is we need to find the value of f of c. We need to find the value of the function at the point c. If this is defined, if the value of the function at point c is defined, then we can say that the function is continuous. If this one is undefined, then we can say that the function is not continuous at c. Am I clear? Yes or no? Yes or no, guys? Am I clear? I hope you guys are clear about the endpoints and you guys are clear about the singleton. Okay, now let's move on to discuss one problem.